Hello, I'm Pete Bellotta. Whether you're cross-cutting a pile of 2x4s or ripping a stack of 3/4 inch plywood, there's no faster way to get the job done than with a circular saw. And while this rotary cutting powerhouse is typically used for home construction and remodeling, it can be just as useful for many woodworking projects when fitted with the right blade and used with the appropriate jig. In this program, you'll see why the circular saw is an indispensable part of any woodworker's toolbox. A circular saw is a rotary cutting power tool designed for speed and efficiency. In addition to ripping and cross-cutting, a circular saw can be used to cut bevels, miters, and chamfers, as well as make plunge cuts. There are two basic types of circular saws: the worm drive saw, which can be identified by its rear-mounted motor, and the sidewinder, so named because its motor is positioned alongside the blade. In a worm drive saw, power is transmitted to a gear on the blade arbor, appropriately enough through a worm gear on the end of the motor shaft. The gears operate inside an oil-filled chamber, which reduces gear wear and prevents overheating during prolonged use. In a sidewinder design, the motor transfers power to the blade using a pair of helical gears. In a worm drive saw, the gearing is designed for high torque output, which makes these saws virtually impervious to stalling, even when cutting wet lumber. In contrast, the helical gears in a sidewinder have an overdrive arrangement, which produces higher RPM with less motor wear. The advertised size of a circular saw is based on blade diameter, with 7 1/4 inches being the most popular. Most 7 1/4 inch saws provide a maximum cutting depth just shy of 2.5 inches at 90 degrees and slightly greater than 1 3/4 inches at 45 degrees. Circular saws also come in smaller sizes, such as this 6.5 inch cordless model. These saws are easy to handle and are designed primarily for trim work. All circular saws are constructed similarly and share the same basic controls. Take a look. The saw's frame serves as a sled that supports the motor and blade assembly and allows the tool to glide along the surface of the workpiece. The frame also contains the cutting depth and bevel adjustment controls. To guide the saw along the cut line, a notch is provided in the base. For greater accuracy, some models are equipped with laser tracking. The blade guard consists of a fixed upper portion and a spring-loaded lower section that automatically retracts as the saw is moved forward. The motor is enclosed within a plastic housing to insulate the user from electrical shock. The two-piece housing also extends into the tool's primary handle. A knob or secondary handle is also provided for two-handed control of the tool. Starting and stopping the saw is accomplished by squeezing and releasing the trigger switch in the primary handle. To prevent starting the saw accidentally, many saws include a switch lock, which must be depressed first before the trigger switch will operate. A feature found on some high-end circular saws is the blade brake, which brings the blade to a stop almost immediately after releasing the trigger. Since most people are right-handed, the blade on most 7 1/4 inch sidewinders is positioned to the right of the motor. This design offers the safety of keeping your left hand a safe distance away from the blade. However, it can make it difficult to see the cut line. This is why some manufacturers offer blade to the left models, which incidentally is typical on most cordless circular saws. Another feature found on certain saws is a dust collection port, which can either discharge into a bag or be connected to a shop vac. Most circular saws come from the factory equipped with a 24-tooth blade, which is designed for general wood-cutting tasks. However, to maximize the tool's performance, it's best to install a blade specifically designed for the task at hand. Saw blades are generally classified according to the material used for the blade teeth, which is either steel or carbide. Although steel blades are inexpensive, they dull quickly, resulting in greater stress on the saw's motor. Carbide blades, on the other hand, cut cleaner and last far longer. These blades are essentially steel blades with carbide teeth attached, and though they are more costly, their durability and performance more than justify the expense. The easiest way to determine the blade best suited for a particular job is by the number of teeth it contains. Generally, blades with fewer teeth, such as an 18 or 24 tooth blade, are designed primarily for ripping dimensional lumber. These same blades also work well for cross-cutting framing lumber since a smooth edge is not important. Notice that the spaces between the teeth of this 18-tooth blade are wide and deep. These spaces, known as gullets, allow for the efficient removal of waste and also help reduce the chance of kickback. Kickback is a potentially dangerous condition that occurs when the material pinches the back half of the blade. As a result, the saw will climb out of the kerf and be thrown back towards the operator with considerable force. Warning: kickback can cause serious personal injury. If the blade binds during a cut, stop the saw immediately, back it out of the workpiece, and then restart the cut. Never force the saw through the material. When a smooth finish is required, such as cross-cutting material for a piece of furniture, use a blade with at least 40 teeth. When it comes to ripping veneers, hardboard, or paneling, use a plywood blade, which for a 7 1/4 inch saw has 150 teeth or more. One of the great things about a circular saw is that it can be used to cut materials other than wood when fitted with the appropriate blade. This silicon carbide masonry blade, for example, is designed to cut block, brick, stone, and slate, as well as soft metals like aluminum. When using a silicon carbide blade, always wear a dust mask to prevent the inhalation of fine particles. To change a blade, unplug the saw and place it on a solid surface with the blade facing up. Next, press and hold the spindle lock button located alongside the upper blade guard. Using the supplied wrench, rotate the blade slowly to engage the spindle lock and then loosen the retaining bolt. With the bolt removed, rotate the blade guard and take off the outer washer and blade. Be sure to clean off the accumulated sawdust around the spindle shaft and blade guard. Install the new blade, making sure the teeth point upward at the front of the saw, and then hand tighten the retaining bolt. Finally, engage the spindle lock and secure the bolt with the supplied wrench. The portability of a circular saw is perhaps its greatest asset. Unfortunately, it's also its greatest liability. That's because you're dealing with a handheld machine spinning a large blade over 4,000 RPM. In this section, I'll show you how to capitalize on the assets and minimize the liability. Before using the saw, always make sure the workpiece is properly supported. For crosscuts, the material should be supported as close to the cut line as possible, leaving just enough room for the blade to pass by the supports without interference. To adjust the cutting depth, raise the blade guard and place the blade against the edge of the material. Next, loosen the depth adjustment knob or lever. Now, raise the saw until the blade extends past the material by one tooth and then tighten the adjustment knob. Always unplug the saw before making any adjustments, and never set the cutting depth too deep, since this increases the risk of kickback. To make a crosscut, place the saw on the workpiece and align the cut line with the notch in the base. Depending on the saw, the notch is either aligned with the inside or the outside of the blade. Now, since blade thicknesses can vary, it's a good idea to make a practice cut in some scrap material first to determine the relationship between the notch and the actual saw kerf. With the saw properly aligned and blade away from the material, start the saw and allow the motor to reach maximum speed. While holding the saw firmly with both hands, advance it gradually through the material, keeping the notch aligned with the pencil mark as you go. Continue to move the saw through the material until the cut piece falls off, and then release the trigger and allow the blade to come to a complete stop before setting the tool down. To make a bevel cut, loosen the bevel knob and tilt the base to the desired angle indicated on the bevel scale. Next, align the notch in the base with the cut line and make the cut following the same crosscut procedure. Chamfering a piece is accomplished in the same way, except that the blade is set so that the edge is only partially beveled. To ensure the accuracy of the cutting angle, place the saw upside down in the 90-degree position, raise the blade guard, and position a speed square against the base and the blade. There should be no gap between the blade and square. If a gap exists, adjust the appropriate set screw to realign the base. When making a cut, never move the saw along the piece that's being cut off. Always make the cut with the saw fully supported. Since the teeth travel upward as they're cutting, Any splintering or tear out that occurs will appear on the upper surface of the workpiece. Consequently, if you're trimming a door or cutting other material where appearance is important, place the workpiece good side down, meaning the side that's exposed when the piece is installed. When cross-cutting wide pieces, use a right-angle fence to guide the saw along the intended cut line. To make the fence, fasten a pair of square 1x stock together in the form of a T. Before adding more fasteners, adjust the pieces against the framing square to ensure accuracy. With the two pieces secured, clamp the jig to a piece of scrap and run your saw along the fence to trim off the crosspiece. This customizes the fence to your particular saw. To use the fence, simply align the trimmed end with the pencil line on the workpiece and then run the saw along the fence for a perfect 90-degree crosscut. Warning: never operate a circular saw without wearing a clean pair of safety glasses and hearing protection. Before using your saw for rip-cutting flexible materials like this 1/2-inch plywood, be sure that the workpiece is supported on both sides of the cut line. This can be accomplished by placing several 2x4s across the sawhorses. When ripping shorter lengths of rigid material like this 3/4-inch particle board, lengthwise supports are not necessary. With the cutting depth properly adjusted, place the power cord over your left shoulder and align the saw with a cut line. Always make sure there's enough slack in the cord so that it can reach the opposite end of the workpiece without interference. With the blade a safe distance from the workpiece, start the saw and wait for the motor to come up to speed. Now, move the saw forward, allowing the tool to do the work. Keep your body slightly to one side and stay behind the saw at all times. However, don't lag too far behind since that can cause you to overreach. If you begin cutting off the line, never attempt to force the saw back in line. Instead, stop the saw and reposition it as needed. For greater accuracy, use a rip fence to guide the saw along the cut line. While most saws come with a fence that allows you to make narrow rip cuts, you'll need to have a straight edge clamped to the workpiece for wider cuts. One of the problems with using a straight edge is that it must be offset the right amount on both ends to ensure an accurate cut. To eliminate potential errors, make yourself a ripping jig. Here's how. Starting with a 4x8 sheet of 3/4-inch plywood or other type of 3/4-inch sheet product, cut an 8-foot length 5 inches wide. Next, cut a second piece as wide as the saw base plus an additional 5 inches. Now, fasten the pieces together and then run the saw along the 5-inch fence to customize the fence to the saw. To make a precise rip cut, simply align the jig with the cut line and clamp it into position. When using the jig, be sure to set the cutting depth an additional 3/4 of an inch so the blade penetrates the workpiece. Circular saws can be used to make interior cuts on a workpiece, such as a window cutout. This technique is known as plunge cutting. To make a plunge cut, begin by setting the blade to the proper cutting depth. Next, rotate the blade guard fully forward to expose the blade. Now, tilt the back of the saw up so that the blade is slightly above the surface of the work, and then align the front of the base with the cut line. While holding the saw firmly, squeeze the trigger and let the motor come up to speed. Using the front of the base as a pivot, slowly lower the rear of the saw into the work. Once the blade begins cutting, release the blade guard and then continue lowering the saw until the base is flush with the material. To finish the job, use a hand saw to cut out the corners and then use a screwdriver to pry out the cutout. Now, let's review the key points of the program. In addition to ripping and cross-cutting, a circular saw can be used to cut bevels, miters, and chamfers, as well as make plunge cuts. There are two basic types of circular saws: the worm drive saw, which can be identified by its rear-mounted motor, and the sidewinder, so named because its motor is positioned alongside the blade. The advertised size of a circular saw is based on blade diameter, with 7 1/4 inches being the most popular. Circular saws also come in smaller sizes, such as this 6 1/2-inch cordless model. These saws are easy to handle and are designed primarily for trim work.